I'm using this dollhouse to demonstrate practical solar.
Hi, I'm Frank Scruggs, the inventor of practical solar. You see, I found a way to store summer's heat in the ground. I had a greenhouse that I couldn't open the windows on because of an experiment we were doing. To cool that greenhouse, I pumped cold water from the well up through a heat exchanger inside the greenhouse and cooled the greenhouse, and then sent the water back to a drain field where it percolated down into the water table. But I had a problem. The groundwater temperature started to go up 2 degrees a month. So later I had to drill a well farther away just to get cold water to the greenhouse. And then it dawned on me that I could do this on purpose. I could store heat in the ground on purpose. So the plan from there was to put a solar collector on the house, pump water up through the solar collector and let it collect solar energy, and let that solar energy percolate down through the ground, heating the whole ground up. And then whenever I needed it, I could pump hot water to the radiator and heat the house. So that's how practical solar was invented, or the idea was brought up. So the three major components are a solar collector, a way to exchange that heat with the house. In this presentation I'm doing now, I'm using a dollhouse that has radiant heat in the floor. And you need a rock bed or drain field, something to simulate the earth, and a well pump.
This is the solar panel I'm using in this demonstration. To make this solar panel, I used a material called plasticor. Plasticor is a corrugated cardboard that's made of polypropylene plastic, a high temperature plastic that you'd normally use like in washer toss containers or something like that. And then I take this plasticor and I glue tubing to the ends of it so that I can pass water through it. Then to insulate it, I use half-inch styrofoam. I put that on the back to keep the heat from leaking out the back of the collector. To keep the heat from leaking out the front, I use a glazing material. This particular glazing material is polycarbonate. Let me take the polycarbonate off. It's 2 layers of polycarbonate in another see-through kind of cardboard plastic. So there you see the cat in the background, the tube that's glued to the polypropylene, and polypropylene on top of the styrofoam, and this is all given structure with oriented strand board. This oriented strand board is commonly used as a roofing material. The oriented strand board and the styrofoam cost about 60 cents a square foot together, and the polypropylene costs another 60 cents a square foot. That's $1.20 a square foot. This glazing here costs $1.60 a square foot. So it's more than the rest of the collector combined. If we can keep the price down on the solar collector, then we can sell a lot more of them. This one has solar cells attached to it to provide power for my electric pump. We could also provide electricity for the house using this way. But we're not in this sample. We will talk about electricity in another video.
Now let's test this thing out.
This solar panel is the same size as the one on top of the dollhouse. So the water's being pumped by this. It's a kerosene transfer pump, normally made to run with 2 D-sized batteries. Getting pumped into this side of the collector, 99 degrees, 96, 106. So
the bucket of pea gravel in the next scene simulates pre-existing subterranean geology.
Outlet water temperature is 87 degrees. Outlet water temperature 87 degrees.
My solar panels can collect $2 a year worth of thermal energy per square foot.
Well, the light's been on for about an hour now. This side of the collector is reading 137. The water out is reading 110. Anyway. Well, at an hour and a half, we have an outlet temperature of about 117. You've seen the solar panel simulator heat the water up in this dollhouse. Now, the same heat storage bin is pumping water through the floor of the dollhouse, going in there, and it's coming out here. The regular floor, the unheated floor in the dollhouse, is 70.8, but the heated floor in the dollhouse is 94.1. And so with a nice warm floor, you're getting radiant heat in this dollhouse.
This proves a solar panel made of plastic core can store enough thermal energy in pea gravel to heat a house.
Just for fun, I turned on the lights. Which we will see in another video.
So what's the big deal? Well, if you have a house that has a $2,000 a year heating bill, you'll only need a 1,000 square foot collector. You would need one 4 times as big if you couldn't run it all year. But because we can store heat in the ground, we only need a tiny collector compared to normal. So, a plastic core collector of 1,000 square foot, even with the expensive glazing on it, is $3,000. Well, if you have 2 pumps, 2 wells, and they're $1,000 a piece, that's $2,000 more dollars. So for a $5,000 system, plus controls and other labor of installation and whatnot, with a $6,000 system, you would pay it off in 3 years. $2,000 a year. Well, a $6,000 system, there's a tax rebate of $2,000 on that, so you only pay $4,000. So it would pay itself off in 2 years. you could purchase this with a credit card and have a lower monthly heating bill paying your credit card payments than installing a furnace system in the house. When solar becomes so economically feasible that it's more feasible than burning fossil fuels, then we won. We will sell the majority of homes in America a system like this. In the home heating market's $160 billion a year. That means people that help me out in this system will probably do well. That's why it's a big deal. Thank you for listening to my video. Frank Scruggs out.